Good day and welcome to the Tintri Live Demo Series. Today's event features SecureVM with the new feature, External Key Management. My name is Bill Roth. I'm part of the tech marketing team here at Tintri, and I'm joined by Brett Schechter from Product Marketing. Good day, Brett.
Good day. Thank you, Bill. I'll also be asking a few questions during Bill's presentation.
Okay, great. And let's get started. So we wanted to go through a little bit of the history of SecureVM. SecureVM is Tintri's branding for encryption of data at rest. What it does is it encrypts the Tintri VM store file system and operating system. It provides increased data security for different threat models. So when did this support initiate? Well, for the hybrid flash series, support was initiated with Tintri OS version 3.1 and higher. This support includes the T600 and T800 series products. Beginning with Tintri OS 4.0 and higher, the all-flash T5000 series was supported. So here's a little bit more on the primer. All these products, all the supported products, the 600, 800, and T5000 series products, ship from the factory with self-encrypting drives. User data, including the OS, is stored in encrypted format using the AES, which stands for Advanced Encryption Standard 256 algorithm. There's zero performance impact and there's zero capacity impact. The reason for that is that the data is already being encrypted on writes and decrypted on reads, whether or not you deploy the SecureVM feature. So all the data is encrypted on writes, all the data is encrypted on reads. There's zero capacity impact because the product has been sized, taking the encryption into account. Okay, more on self-encrypting drives. When they come from the factory, they include a media encryption key, an MEK. This is generated by the manufacturer. This key is stored within the device. All user data written to the drive is always encrypted. This feature of a self-encrypting device cannot be disabled. So the drive or device comes from the factory. The key is built into it. It's a manufacturer-generated key, and the key is fully exposed. Okay, so how do you turn the feature on and what does it do? Well, when we enable something called authenticated access mode, what happens is we require the use of an authentication key to access the manufacturer-generated media encryption key. So if we look at the graphic, we can see the manufacturer-generated media encryption key fully exposed. Okay. When we enable the SecureVM feature via installing a license, what happens is we obscure or restrict access to the media encryption key. Okay. So the key's still there, but you can't get to it unless you've got an authentication key. Okay? So each authentication key is a randomly generated 256-bit number stored internally to the Tintri VM store in segments. Okay, so each one of the authentication keys is broken into segments and stored internally to the VM store. Okay, so that's the history of SecureVM. We just wanted to run through a few data points as review at this point. So when enabling SecureVM, any existing data is already encrypted by virtue of the self-encrypting drives. So if you were going to ask a question, Brett, when I enable this feature, how long will it take to encrypt the data that's already on the Tintri VM store? The answer is the existing data is already encrypted. Okay? License key and enablement invokes authenticated access mode. Okay, so authenticated access mode unlocks access to the media encryption key through the use of an authentication key. So over on the right side, we have a couple more data points, and these address the threat models that SecureVM covers without external key management. So the data is secure if one or more drives are misplaced or stolen. For instance, you had a defective drive, your Tintri VM store keeps running, and tech support ships you a replacement drive, and you want to do a return merchandise authorization, an RMA, on the defective device, you can ship it back securely, knowing that the authentication key is not present on that device, and that blocks access to the media encryption key. So nobody can get to the data when you return a drive if that drive was misplaced or stolen or otherwise mishandled. Okay. The second point here is real important. The data is not secure if the entire VM store is misplaced or stolen. So the use case here is you're shipping a Tintri VM store across campus, across the state, across the country, or to a different continent, and the carrier loses it or misplaces it, or it's purposefully stolen. The reason for that is that the authentication keys are stored within the VM store itself. So the threat model that this covers is very limited. It's essentially RMAing a defective drive. Okay, let's introduce the new feature, Brett, where we talk about external key management, which was initiated with Tintri OS version 4.3. Now, OS version 4.3 became generally available in January of 2017. This feature is supported with the same products, the T600, 800, and T5000 series products. It still uses the same self-encrypting drives. The difference here is that the authentication keys are not stored on the Tintri VM store. Instead, they're stored on a SafeNet KeySecure server. So this is an external key management server. That's where the keys are kept. And let me tell you, they're a lot more secure. So today it's supported with KeySecure versions 8.2 and 8.4. This can be deployed as a virtual or physical key server. So any questions at this point, Brett?
Bill, excuse me, we do have a question. There's a question about how this would be fulfilled. So how would a customer purchase this? Is it currently available? And do they work through Gemalto?
Yeah, it's a great question. So the SecureVM license comes from your Tintri reseller or your Tintri account team. You can simply call Tintri if you want that key, and we'll run through key installation in just a moment. The Gemalto part of this, the SafeNet KeySecure product, needs to be purchased either directly from Gemalto or through one of their certified resellers. Okay. Beyond that, Tintri can help you get in touch with Gemalto or a Gemalto reseller for that matter. So if you're an existing Gemalto customer and are switching from a different legacy array, modernizing with the Tintri VM store, and you already have Gemalto, it's just a matter of buying connection licenses. And you probably already know how to contact them. If not, contact us here at Tintri, and we'll get that straightened out for you. So that's a great question, Brett.
Thank you. So
what we want to run through, and we've been doing a lot of slideware, and I apologize for that. It's a significant feature with a lot of new things. So we wanted to make sure you understood where we were coming from and where we're going in the future with external key management. What we've got here is an animated slide where we run through what happens when we power on the Tintri system from a cold state, so it's completely powered off. The first thing that happens is we check for the presence of an external key management config file. That's the EKM underbar config file. We do this on both controllers. We're only showing the controller on the right to keep the slide a little bit simpler. At that point, we enable the networks and determine if the other controller is primary. Okay, so there's actually an internal bond that connects the two controllers so they can communicate with each other. Okay. We also bring up the external management interface so the controller can talk out on the local area network and access the SafeNet key secure server if need be. Okay, so step 3, the other controller is not primary in this case because it too is powering on. Because it's not the primary, it connects to the key server and exchanges certificates. Now this is kind of important, and these certificates, what they really are is they represent a form of authentication and authorization. So the CA cert is the certificate authority certificate. That gets sent from the SafeNet key secure server back to the controller. At the same time, the controller sends over its signed client certificate. So this is a RSA certificate that actually has been signed by the certificate authority. So he knows that that's his signature on there. It essentially says, I am who I say I am, and vice versa. So everybody knows who they're talking to here. At this point, what happens is the controller requests keys from the key server. Okay, so it says, give me the authentication keys. They send the keys back. At this point, the controller unlocks the drive. The controller disables any networks that were enabled and boots normally.
So Bill, would this array be able to boot if for some reason this process were interrupted?
Yeah, if this process did not complete successfully, the answer is no. This controller would not boot, and we'll run through a brief demo of that as well.
Before we get to the demo, one additional question just came in. Is this supported on all existing Tintri arrays? How many generations back does it go? Is there just a limited set that supports this?
Yeah, so we covered that early, and to recap that, what we're looking at is the T600, 800, and 5000 series products. These are the ones that ship with self-encrypting devices.
Thank you.
Right. Earlier products such as the T500 series, a T540 for instance, did not ship with self-encrypting drives, so the feature's not applicable. Okay, one other thing before we get into some live product. When we look at external key management, we're going to see some console messages. Some of those console messages include messages like unlocking disks using external Keystore. The Keystore host is going to be the fully qualified domain name of the Keystore management server. There's a port number, and there's also a key prefix. It's important to note that this key prefix is in fact the serial number of the Tintri VM store. Just wanted to hit on that before we go any further. So at this point, let's go into a live demo. First, we're going to look at a Tintri VM store. And it's one that we've got set up for this demonstration. So first things first, let's go to Settings, and this will take a few seconds to come up. Okay, so we click on More, and at this point we can look at licenses. Okay, so you can see we have an installed SecureVM license here. Okay, further down we can see that external key management has been configured. We have a client certificate. Okay, We also have a server certificate authority certificate. This is, again, so when these certificates are exchanged, that the Tintri VM store can make sure it's talking to the correct certificate authority server. We've also detailed the fully qualified domain name of the key management server that we're going to be using. Okay, let me cancel out of this and let's come over to the actual Gemalto SafeNet Key Secure Management Console. So we'll go ahead and log in. Now, the first thing you should note is that this has a totally different point of administration, Brett. And what that means is the person or persons who have administrative access to the Tintri VM store will not necessarily be the same people that have access to the Key Secure Management Console, right? So you can separate or divide the power such that you have security people adminning encryption keys, and you have other admins, such as virtualization admins, administering the Tintri side of the equation. So after we log in, what we wanted to do was take a quick look at some of the things we talked about. So here we've got the local certificate authority, and we named it DPL-cert for Data Protection Lab-cert. Okay, we've added that to a list of trusted certificate authorities, and we've left the name at default for the authority list. Okay, nothing fancy there. Okay, the other thing that we've done here is we've generated some certificates as well, but what we really wanted to do at this point was come over and look at one of the protocols that we've configured. It's called KMIP. So this is the Key Management Interoperability Protocol. It has an IP address, it's got a port number, and we say use SSL. It's also got a server certificate. Okay. We've got some other settings here that are pretty interesting as well. But what we really wanted to focus on at the moment was to come back to security, and we wanted to look at these keys. So what we've got here, we have a test key from when we set this whole thing up, and then we've got generations of keys. It runs 0. I think the highest one here is going to be generation 13. We can go to the next slide. We can see another test, and we can see a master key entry. So the purpose of the master key entry is that it defines the current key generation used for a particular Tintri VM store. Now,
so Bill, just in case, just in terms of best practices, will our end users typically put an expiration date on these keys? Is there a common rotation pattern that we've seen?
Those are great questions. At this point in time, the keys do not expire. You can delete keys if you want to, but I want to put some cautionary statements around that. You can rotate keys manually. Okay, and again, there's going to be more cautionary statements. The thing here is your data is very secure using this secure methodology. You lose the keys, you lose your data. This should be taken very, very seriously. So here you see Tintri-VM store -- and again, this is the serial number of the Tintri VM store. So our customers that have 10, 20, 30 Tintri VM stores can pretty easily identify which keys belong to which Tintri system. Okay, so again, the master key defines the current generation key being used, and if I'm reading this correctly, Gen 13 is our most recent key, and we generated this back on February 9th. Now, one of the cool things that we can do, and you just talked about this, Brett, was do a key rotation. So here on the Tintri VM Store UI, I'll go to the Hardware tab. So the use case may be, hey, we rotate keys once a month, once a week, just because that's what our site procedure says to do. Or you may have actually had some kind of a threat where you think your keys have been compromised. You think somebody maybe stole those keys. You had a rogue employee who had access to the key management server. They may have the keys for this Tintri VM store. I'm getting ready to ship it across the country. Guess what I can do? So here I see that the last rotation was on February 9th. Okay, I'll click it. I'll say, rotate the key. We get a nice dialog attempting to rotate the encryption key. This may take a few minutes to complete. It typically takes a minute to 2 minutes, probably a minute and a half. Now, we saw that the last timestamp on that was February 9th, if I remember correctly. So what we're going to do is we're going to come back here to the Key Secure Management Console. I'm going to go ahead and do a refresh. And here we see generation 14. Okay, so we were running on 13. We thought we had some kind of a threat. We rotated keys. Now we're on Gen 14, and you can see an updated creation date here of February 23rd, 2:52 in the afternoon, which reflects the current timestamp. Now, just to reconcile this with the Tintri VM store, we'll refresh this display. We'll come back to the Hardware tab. And we'll hover over disks again. And this still says February 9th. So remember I said it would take a minute or two to update. So what we'll do is we'll refresh this again. We'll come back to the Hardware tab. We'll hover again. And there we get February 23rd. So both pieces of information align, and we've successfully rotated keys. Now, when we do that, some of the things that you said earlier, Brett, were kind of serious about deleting keys, expiring keys, right? So it's manual expiration, rotating keys. So here I've got this new key. If I was to shut down the Tintri VM store, or for any reason it needed to come out and access the key management server and get this current generation key, which is defined by the master key, it's pretty important that I have these keys, because if we can't serve these out, the operating system and all the data on that Tintri VM store is locked for good, and we're out of luck, in effect. So what we want to be able to do is we really want to be able to back up those keys in case we had an event from which we needed to recover. So I typically, just for the demo, I'll do select all on the backup utility. I'll continue. I'll back up everything, the entire configuration of the key management server. We'll continue. Here we've got to give it a name. We usually plug in something simple like test, and we'll put in 02/23/2017. I think that's what we're looking at here. And paste that into the description as well. Now, this is kind of neat. You also have a backup password. Another level of security for your backups. Okay, and we're going to download this to the browser. So I'm going to download this to a different system that is deemed to be a secure system. We'll click backup now. Okay, so that's how you back up. There's also a restore utility in case you needed to recover that key. It was inadvertently deleted or you had to rebuild a key management server for some reason. So with that, there's another neat feature here that I really want to cover. We'll come back to security. We're going to look at the keys. Here's our Generation 14 key, which is the one we just rotated into place. One of the things that I can do is click on Properties. Now you can see there's a field here, Exportable. Well, what that means is that this key can be exported back to a client that needs that key to unlock something. If I click Edit, I can deselect the exportable field and I can save. Okay? And what does this mean? What really happens when I enable this feature? Well, what I wanted to do was skip to a quick little video where we take a look at that. And what this is called Crypto Lock. And we'll go ahead and we'll play this for you. And what we did here was we powered on the controllers on the Tintri system, and we had a console port connected. And we can see both controllers booting here. Controller B in the lower right, controller A in the upper left. And what happens, and this mimics what we saw in the animated slide earlier, we bring up the interfaces, we check to see if the other controller is the primary controller. Neither of them are. Okay, then there we see it goes out to the fully qualified domain name of the key management server, the port number, and it's looking for a key prefix. That's the serial number of the Tintri VM store. And you can see it's denied. The same thing happens on controller B in the lower right, and it's game over. So Crypto Lock, it protects against another threat model. Okay, so we think we've had some kind of a breach in a data center. We powered down the Tintri VM store. We unexport the current generation key. The bad guys come in, they try to power it back on, or they steal it and they try to power it back on. Even if it has network connectivity to the key management server, it can't get the keys because they've been unexported. Okay, let's see if I can intelligently come back here. So what I really wanted to do so that we don't have problems later on in the day or in the week is I'm going to make those keys exportable again so we don't have that happen in the lab when we're running a different demonstration. But that's a quick look at what the key management interface looks like. And as you can see on the Tintri side of this, you can rotate keys. You notice how this turned red here. And the reason for that was because we actually did unexport the keys. So we'll come back and that'll be fine when we get back. Okay. External Keystore operation failed. So let's try that again. And there it is, back to green. So when we unexported that key, we got an indication that the status was bad here on the Tintri VM store as well. So you can see that everything's reconciled, everything's correlated, and this really does work. So at this stage, what I wanted to do was come back to our PowerPoint deck and just take a look at the key points, the key data points that we already covered here. So the data is, again, secure if one or more drives are misplaced or stolen. And that covers the threat model where you're going to RMA a defective device back after you've received a replacement. Data is also secure if the entire VM store is misplaced or stolen. This is the threat model where you're shipping the entire array across campus, across state, to another continent. We also see that we had the ability to cryptographically lock the array by disabling key export. We unexported the key, and guess what? When those controllers try to boot up, they can't get the key, and whoever's doing this is denied. They're clearly not going to get the data. Now, the other threat model that this kind of bypasses is the idea that we've got separate admin teams for the security side of the house and the virtualization side of the house. So it really adds to the capabilities of SecureVM. Brett, did we have any new questions?
We actually have one very short question. So if the array is in transit, let's say from one location to the next, would you want to go in and cryptographically lock the array, disable the key export capability until you know that the array has arrived and it's in proper hands? So if we were creating a best practices guide, is that a step that our customers should follow?
Yeah, and it's actually part of the Gemalto documentation and best practices suite of information, and absolutely yes. At the moment I power that array down, I want to unexport the current generation key. I want to leave that unexported in case somebody, the bad guys intercept the array, steal the array, stumble upon the array, and turn it back on. We don't want it to connect over the network and have access to those keys. So yeah, that would be a best practice. If we were going to ship an array, we would definitely want to cryptographically lock it by disabling key export. That's a great question.
Thank you, Bill.
And with that, Brett, I'd like to thank everybody who took the time out of their day to join us. And thanks again, folks.